Hello everyone, this is Team Project Honor. What we built is a quantum secure email client application. Let me first begin by talking about the architecture of our project. So, our project follows an event-driven architecture, and we divided the system into four primary layers and one expansion zone. The four primary layers are the user interface layer, the application core layer, the service layer, and the external integrations layer. We also have a future expansion layer that allows new features to be added into the system in a very modular fashion. It's just plugging the new modules into the system via the event bus. So the primary reason that we went with an event-driven architecture was to allow allow extreme modularity. Every single component that you see in this diagram is just a module that can be plugged into the system. Let's just start talking about the user interface. This is what the user directly interacts with. It includes four main modules. The main dashboard gives users an overview of all messages and notification. The settings panel lets users customize preferences securely. The inbox view displays incoming mails efficiently. The compose email view enables composing and sending messages. Now, the important thing that you have to keep in mind is each component works independently and communicates with the application core using well-defined interfaces, keeping the UI layer completely modular and easy to enhance later without modifying anything in the service layer. Now, let me talk about the application core. The application core, which is highlighted in purple over here, acts as the central control hub. It includes a controller manager, which manages communication between the UI and the backend services, a security level selector, which automatically applies the right encryption policy, for example, switching between standard and quantum encryption modes, and an event bus, a modular communication backbone that connects all services asynchronously. Because of this design, we can add or remove modules without affecting other parts of the system. Perfect modular scalability is enabled because of this particular decision. Let me talk about the service layer next. Moving on to the service layer, this is where the core processing happens. It includes a message processor for handling the email traffic, an attachment handler for secure file processing, an account manager for authentication with Gmail or Yahoo or really any other service that allows SMTP protocol. We also have a security policy engine which talks with a crypto engine that allows for encryption, and we have a data storage module for that manages both local and cloud-based data. We also have a sync controller to keep multiple devices in sync with the database. Now, each service runs again as an independent module, which means developers can upgrade or replace one service, like switching to a new encryption engine without touching any other part. So one team can be working on a particular component, another team can be working on this particular component, so they can work pretty much independently without bothering the other teams in their work. This allows for modular development as well as modular usage. So this layer truly represents the core ideology of our architecture. We wanted a loosely coupled application because the problem statement mentioned that modularity is one of the important things that the email client should have. So let me move on to the external integrations layer, which is shown in orange. This layer connects our system to the outside world through well-defined APIs. So we have a local database or a cloud sync database, a database on the cloud. We can easily integrate that using this particular component. We can also communicate with Gmail or Yahoo Mail API or any other SMTP supported platforms through this particular component. We can also connect in the future if a quantum key distribution server is successfully set up. We can easily move from the simulated environment into this real environment because our simulated environment strictly adheres to this particular standard. Standard compliance was a very important thing that we kept in mind when designing the QKD simulator. So really, if a quantum key distribution server becomes active, the transition from this fake simulated environment to this real environment is seamless. The most exciting part, of course, is the future expansion zone where new modules can be integrated into our application via the event bus and the security core. These are the two modules that will be modified slightly to incorporate these particular future expansion zones. So adding new functionality does not require the redesigning of our system. It's just simply a plug and play process. So let me illustrate the flow of our application. Our user composes an email, the control manager receives it, and the security selector, if need be, applies a particular security level in order for the security policy engine to understand that and then talk to the crypto engine to enable that allows the communication between the QKD and also standard protocols like AES or one-time VAT. So that's the purpose of the security level selector. And it goes to the event bus. And of course, like any other event driven architecture, the event gets published and the subscribed modules then start working to make that process happen. So this system, every step in the system follows a modular, secure, and traceable flow, ensuring reliability, consistency, and quantum grade security. Now let me show you the code base of the architecture that I discussed earlier with you today. So this is our implementation of the application. We split the code base into the core module, the user interface module, the integrations module, and all of the modules are clearly independent, as you can see in the code base. And we also have tests to test each service independently if need be. And we also have the QKD implementation, which complies with the HC protocol. As you can see, every single parameter in the protocol is satisfied in this implementation of our quantum key distribution service, the simulation. So the simulator, switching from the simulated environment to the real environment requires very little effort because of the standard compliance that our QKD simulator provides. And in order to actually run this, we are running this on a Docker container to make it similar to the real QKD network that will be implemented in the future. This is the runtime of our graphical user interface. As you can see, this is my inbox. And here, if I go to the mail provider, I won't be able to decipher what the actual message is. But if I go to the client, the QMail client, I'll be able to see the hello Akash. I sent this email to myself using the compose functionality, which is over here. And we can also refresh the inbox. We can choose which layer of security that we want to access right now. Thank you.